Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, thank you Dr. A for that amazing introduction. I'm so happy to be back with you all. Last week we had some technical difficulties, and the week before that we took off for the holidays. So I haven't seen y'all in 2 weeks. So welcome back to Math Night. For those of you who are new, my name is Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And I'm just so thrilled to spend my Wednesday nights with you, just solving through a few math problems that you could see on your certification exam. So, like Dr. A said, we go through a variety of problems. We go through everything from pre-K through 12th grade. Most of the problems that I choose for us to do or I build for us to do are problems that kind of sit right in the middle so that I can stretch them up and stretch them down for whatever exam that you're prepping for. So, before we begin, here's what I want you to do. I want you to comment in the comment section and let me know where you're from and what exam you're prepping for. That way, I know kind of how to gear the conversation if I know what exam you're prepping for. And I just like to know where you're all from. I'm from Central Florida. I am a math coach, and I am certified K-12 math and also some other things, PE and educational leadership. But my passion is elementary school math and leadership, definitely. So, where are you from? What test are you prepping for? And if you want to throw a New Year's resolution in there, you can do that as well. I don't do New Year's resolutions just because I can't stick to them. I do like a word of the year, but I don't do New Year's resolutions. But if you do New Year's resolutions, let us know what your New Year's resolution is. So without further ado, let's go ahead and get started with my first, with the first problem. Hi, Stephanie. Oh, I hate when we don't get our scores right away. When I take those certification exams, I want to walk out of that room and get that piece of paper from that lady. I haven't taken one in years, but I want to get that piece of paper that says unofficial results, pass or fail. So I apologize that you did not get your score. Hi, Kelsey. Welcome. The GK tomorrow. Good luck. I'm sending you all the positive vibes. All right, let me switch this screen so you can see this problem a little better. A teacher asks her students to represent the number 43 thousandths in different ways. Students showed the number in the following ways. Student number 1 showed 0.043. That is not how I would normally read these decimals, but I'm reading them this way so that you don't get a little insight into what the answer is right away. Student number 2, 0.04 plus 0.003. Student number 3, 43,000, or 43,000. Student number 4, 43 over 1,000, or 1,000. Which student has a misconception of how to represent the decimal 43 thousandths and why? Student 1, because the number 43 thousandths should be written as 0.43. Student number 2, because the teacher did not ask for an addition expression. Student number 3, because thousandths represents a number less than 1 or a decimal. Or student number 4, because the student does not have place value understanding and should have written 430 over 1,000. Hey, Hope, how are you? Ooh, Dallas. My husband's from Dallas. Go Cowboys. Although the game this weekend, don't even get me started. All right, so which of the students has a misconception? Now, here's what I don't want you to do. I don't want you to see a problem like this and freak out and get overwhelmed because it's so many words. It's so many words, but after we read it, we realized we can do this. This isn't that difficult. We just have to look for a misconception. So we're looking for the student who did not represent 43 thousandths. Now, because we see this DTHS at the end, we know it's a decimal. If we look at place value, let's do a quick review of place value here. So here's my decimal. This would be my ones place, tens, hundreds, thousands, 10,000s, 100,000s. So ones, tens, hundreds, thousands, 10,000s, 100,000s, and so on. Yes, Kelsey, let me finish this problem and then I will absolutely do that. Thank you for the reminder because I always forget, don't I? And then after the decimal or to the right of the decimal, we're looking at tenths, hundredths, thousandths, 10,000s, 100,000s. So we see that after the decimal point, we have that THS at the end, and before the decimal point or to the left of the decimal point, we do not. So we're looking for a number less than 1. So really, in this case, right here is the only one that is a number less than 1. So it's student 3 because thousandths represents a number less than 1. So then why is student 1 correct? Well, because we've got tens, hundreds, thousandths. So we can read that as 43 thousandths. 43 hundredths would be this one right here. So that's why A is wrong. Letter B, all we did is use expanded form. So like if I had 43, I could rewrite that as 40 plus 3. I can do the same thing with decimals. I can take the 4 hundredths and the 3 thousandths and split them up into an addition equation. Do not get tricked by this. The teacher did not ask for an addition expression. Is this a representation of 43 thousandths? Absolutely. So it's still correct. And letter D, this is 43 over 1,000, which is literally 43 thousandths. So we definitely know that that one's correct. This would be read 430 thousandths, which could also be translated into 43 hundredths. If I wrote that as a decimal, we would have 0.430. And we know that if we have a 0 on the end of a decimal, it doesn't change the value of that number. So this is the same thing as 0.43 or 43 hundredths. They are the same thing because we can divide both of these, the numerator and the denominator, by 10. So that's problem A. Problem A is just listed as problem A and not problem 1 because it came from a slide deck from before, and I always like to make sure I get to all of those problems. So that's problem A. If you're just now joining us, welcome. Don't forget to drop in the comments where you're from and what test you're prepping for. I see a lot of people prepping for the GK, a few people prepping for the EC6 and the Praxis core. Let me go ahead and drop the link to these slides so that you guys can save them. So here is the link for the slides tonight. You will not get the notes, but you will get the blank slides with all of the questions. So definitely an excellent resource for you so that you can continue to study with these problems later on. All right, another GK friend. Hey, Amy, welcome. All right, how many ways can one select 4 colors from a set of 17 unique colors without replacement if the order does not matter? How many ways can one select 4 colors from a set of 17 unique colors without replacement if the order does not matter? This is a probability problem, and I'm actually going to come back to this problem at the end. So we're going to skip this problem. I'm going to come back to that one. I'll explain why later. So below is an image of a rectangular field. If Sophia runs from W to X to Z to Y, how far did Sophia run? So a lot of people are going to take this problem and they're going to immediately think perimeter, which isn't a bad thought, actually, because we know that perimeter is the linear distance, perimeter is the linear distance around a shape. The linear distance around a shape. And we know that area is the square measurement of the inside of a shape. Of the inside. So if we're running around a field, we're definitely looking at perimeter, which is just the distance around our shape. Now, that said, what path is Sophia taking? Let's go ahead and look. She's going from W to X to Z to Y. Very interesting path that she's taking. So don't get tripped up and think automatically that she's going W, X, Y, Z. All I have to do is add those 3 sides up. This looks very familiar to a problem we did a couple weeks ago, except we're taking a different path. So she's going from W to X to Z to Y. That said, we know that this side is 75, so we know this side is 75 because it's a rectangle. And a rectangle has 2 sets of congruent parallel sides. That's important when you're starting to classify shapes, pre-K through 3 and K through 6 people, EC6. You can absolutely classify shapes. They might ask you, which of the following shapes has the following characteristics? A rectangle has 2 sets of equal parallel sides. So I know this is 75 and this is 75. So I know that I'm doing 75 plus 75 plus the length of that diagonal. How do I find the length of that diagonal? Well, I know that this side is 310 because this side is 310. And I know that this is a 90-degree angle because rectangles have 90-degree angles. Another important classification tool that you need to know. So because that has a 90-degree angle, and I know that this side is 75, and I know that this side is 310, I can go ahead and shift my thinking to the Pythag theorem. The Pythag theorem, or the Pythagorean theorem, says a squared plus b squared equals c squared. What does that even mean? It's on a formula sheet if you're taking the GK, but if you don't know what it means, it's not helpful. I think it's on the formula sheet. Don't quote me on that. So a squared plus b squared equals c squared. Well, that just says that in a right triangle only, it only works with right triangles. Do not try to use the Pythagorean theorem with a triangle that does not have a 90-degree angle. It's not going to work. So in a 90-degree angle, we have A, B, and C. C is always, always, always across from that 90-degree angle. And then you have A on one side and B on the other. It doesn't matter if this one's A and this one's B, or if this one's A and this one's B. It does not matter, just as long as those legs are your A and your B, and the hypotenuse, which is across from your 90-degree angle, is C. So I can use that to find this missing angle, or this missing side. It's not an angle. So this is going to be A, this is going to be B, and this is going to be C because it's across from that 90-degree angle. Again, if you called this A and this B, doesn't matter. So let's go ahead and solve that. A squared plus B squared equals C squared. 310 squared plus 75 squared equals C squared. 310 times 310, I'm going to definitely use my calculator, is 96,100 plus 75 times 75, because that's what square means, 5,625 equals C squared. Add those two numbers together, and we get 101,725 equals C squared. And if I square root that value, I get C is approximately 318.9. 318.9. Add that to 75 and 75 again, and we get 468.9, which rounds up to 469. So that right there is going to be how we find that value. Now, they might have said, what's the distance from WX to Y to Z? And then we would be able to just add around that shape, but that's not what they did this time. They made us use multiple things to solve one problem, which isn't surprising. Most of the time on these kinds of exams, you're expected to pull multiple pieces of information to solve one problem. Let's go ahead and go to problem 2. If you're just now joining us, the link for tonight's slides was posted a little bit earlier. I'll post it again at the end tonight, and you can just copy that link and get a copy of these slides. Also, don't forget to let me know where you're from and what test you're prepping for. It helps me help you during this conversation. If 4x minus 6 times 5x plus 3 equals ax squared plus bx minus 18, what is the value of 2a plus b? This might look like a foreign language to some of you, and that's okay, but don't let it intimidate you. What we know is this is going to automatically create a quadratic. So all they're saying is if this equals this, what is this? Well, if we can find what this is, then we can find A and B and just plug them into that expression right there. For those of you who are familiar with quadratics, you should see this right here and immediately think that that's going to create a quadratic. A quadratic is just an equation that when graphed creates a parabola, which can look a lot of different ways, but it's a U or an upside down U. And we know it's going to look something like this when we multiply it out. Let's talk about how to multiply that out. We have 4x minus 6 and 5x plus 3. We're going to use FOIL, or really, it's just the distributive property. So many of us learned FOIL in school, first, outer, inner, last, but really all you're using is the distributive property. All you're doing is distributing this value through, and then you're distributing this value through. Because when we use the distributive property, A times B plus C, we're taking A and multiplying it to everything in the parentheses. So it becomes AB plus AC. But what we know, and we just disconnected, that's always fun when that happens. But what we know is when we're doing FOIL, we can do the same thing. We're taking that first term and distributing it through, and then we're taking the second term and distributing it through. So let's take that 4x and distribute it all the way through. 4x times 5x is 20x squared, because x times x is x squared. 4x times 3 is 12x. Negative 6 times positive 5 is negative 30x. Negative 6 times positive 3 is negative 18. Now I can simplify. I can only combine things that have like terms. So I'm going to combine those two items, and I have 20x squared. 12 minus 30 is negative 18. Yep, negative 18x minus 18. If, as I'm solving these problems, you're stuck, you have a question, you're wondering if it's on your exam or not on your exam, don't hesitate to ask me questions in the comments. I love answering questions in the comments. So if you're confused, stuck, not sure what I'm doing, don't hesitate to ask. I'm more than happy to answer. Hi, Sam. Hi, Katie. Hi, Ethan. Hi, Margaret. Welcome. It's good to see you guys. All right. So now that we have this, what does this even mean? Well, what they told us is this equals ax squared plus bx plus c. So all I have to do is match the A and the A, the B and the B, and plug it into the expression that they gave us, because that's what they want. They want the value of 2A plus B. Well, A is 20 and B is negative 18. So now I can do, I'm going to switch colors, 2A plus B. A is 20, so 2 times 20, plus B. B is negative 18. Do not leave that negative alone. B is negative 18, not positive, because in the problem it's a negative. Don't get confused that we have a subtraction sign. I hear so many people say, but that's a subtraction sign. Yes, you're right, but in our original, we have a plus sign here. Hey, Justin, I recognize you from the Facebook group. Good to see you. We have a plus sign in the original and a minus sign in our problem now. So B is a negative 18. 2 times 20 is 40, minus 18, and 40 minus 18 is going to give us positive 22. All right, done with problem 2. Any questions? All right, let's move on. A regular hexagon has a side length of 12 centimeters. What is the area of the hexagon? So often people will just start Googling hexagon area formula. You do not need to memorize the hexagon area formula, because there's a quick and easy way to solve this. So I'm going to try to draw my best hexagon here. Give me a second. Hey, it's not terrible. There's a hexagon. So we have a regular hexagon. What does this word regular mean? Regular means when we're talking about shapes, all the sides are equal. That's your clue. So if we're talking about shapes, a regular hexagon, a regular triangle, a regular pentagon, a regular quadrilateral, it means that all the sides have equal length. So with that said, let me ask you a question. what would a regular quadrilateral also be called? What would, I don't know why that happens, and it happens at least twice when we're sitting here together. What would a regular quadrilateral be called? A square, because all four sides would be the same. So when you see a regular quadrilateral, it's literally going to be a square. So going back to our regular hexagon, and my iPad there we go. It doesn't want to connect to my Mac right now, so just give me a second. It's making me type in the code again. This is just great. I love it when this happens. All right, so a regular hexagon. We're back. Are we back? Come on, computer. We might have to go paper pencil on you. There we go. Okay. Hope it doesn't happen again. So here's our regular hexagon. Each side has a side length of 12. Okay. So we've got these side lengths of 12. Now, what we can do is figure out how to find the area if we don't know the area formula. How are we going to find the area of a hexagon if we don't have the area formula? Well, what shape can we create from this? I can create equilateral triangles inside my hexagon like that. Now, if I find the area of one of the triangles, can I multiply that area of a triangle times 6 to figure out the area of my hexagon? Absolutely. So we can go ahead and drop a height here, which means if I drop that height right there, I can go ahead and cross this 12 off and know that this is going to be 6, and I know this is going to be 6. Well, what else do I know about these triangles inside of this hexagon? Well, I know that they're going to be equilateral triangles. So I know that this is going to be 12. 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 All of those are 12. And I could prove that to you in 1,000 different ways using different angles and all of that. But I am not going to right now because we don't have time for that right now. But I could prove to you why that those are going to all be equilateral triangles. So now what I can do is use that Pythag theorem that we used earlier, because this is going to be a 90-degree angle and this is going to be a 90-degree angle, to find the height of that triangle. Because the area of a triangle is 1/2 base times height, where this is going to be my base. So my base is going to be 12, and my height I'm going to find by using the 12 and the 6. So we have 6 as our base, or one of our A's and B's, and we have 12 as our C. Is that making sense? So now I can do A squared plus B squared equals C squared. And I can do 6 squared plus B squared equals 12 squared. Why is the 12 there and not where the B is? Because the 12 is across from the 90-degree angle, which makes it that C value that we were talking about earlier. So 36 plus B squared equals 144. So B squared equals 144 minus 36. And that's 108. So B squared equals 108. And now when I look at my answer choices, I'm actually not going to square root that in my calculator because my answer choices actually have square roots in them, which means it doesn't mean that that's going to be the answer, but it means that they didn't use their calculator to estimate. They're using exact answers. So now I need to take 108 and figure out that factor tree to figure out what I'm dealing with. So I have 108 is 2 and 54, and 54 is 2 and 27, and 27 is the same thing as 3 times 9, and 9 is the same thing as 3 times 3. So to get my accurate answer of what the square root of B is, I can do my partners here. So if I have a partner, that means I can pull it out of my square root. So right now we're looking at the square root of 108. But 2 times 3 is 6. So the square root of 108 is actually the same thing as 6 square roots of 3. Lisa, I'm sorry you think this is so difficult. I'm trying to make it as easy as possible. That's my goal. But I'm sorry you think it's so difficult. Yes, it can be difficult. And this is something that you might see on the GK or the Praxis core or anything like that. So now we know the height of the triangle is 6 square roots of 3. I'm going to change colors so it doesn't get lost. 6 square roots of 3. What does that mean? That means that the height of my triangle is 6 square roots of 3, which also means I can now find my area. So the area of my triangle is going to be 1/2 base times height. 1/2 of 12 is 6. And 6 times 6 is 36. I'm just going to leave that square root of 3 alone. Don't let that square root of 3 intimidate you. That's the area of one triangle. Just this triangle. I have how many of them? I have 6 triangles. So now if I just multiply 36 square roots of 3 times 6 triangles, 36 times 6 is 216. So the area of the hexagon is 216 square roots of 3. Now, for those of you who love formulas and you love to memorize formulas, let's look up the area of a hexagon formula. The area of a hexagon formula is 3 square roots of 3 divided by 2 times a squared, where a is a side length. If that's easier for you, then go for it. If memorizing that formula is easy, so let's go ahead and use that formula to solve this problem. Area equals 3 square roots of 3 divided by 2 times the side length. The side length is 12. 144 times 3 is 432, because 12 squared is 144, and 144 times 3 is 432 square roots of 3 divided by 2. 432 divided by 2 is 216 square roots of 3. Would you look at that? We got the same answer. I don't like to commit formulas to memory personally, but if you don't mind that and you just want to memorize the area of a hexagon just in case you get this problem, then go for it by all means. That will not be a formula that's on any formula sheet, but if that's what you want to use, then go for it. Stephanie, exactly. That's why we have to really understand some of the formulas to be able to apply them. It's a great question. So Stephanie said she doesn't even know which formula to use and when to use them. And I get that so often, which is why a formula sheet's not helpful if we don't know how to use it. That's why I like to just commit a few formulas to memory and just use them all the time. So in this problem, we used area of a triangle, which you will use all the time. So knowing that and how to use it is excellent because you can use that in a lot of different problems. Knowing that Pythagorean theorem is going to be super helpful a lot. And then applying that here is going to be the tricky part. But again, if you want to just memorize the area formula for a hexagon, go for it. All right, problem number 4. The apothem of a regular quadrilateral is 7 inches. What is the area of the quadrilateral? So, and I saw Hope got this answer correct. A regular quadrilateral is just a square, because we just talked about how when we see regular, it means all the sides are the same. So I'm going to draw a square, and we're going to disconnect our iPad as usual. I must have something like my hand that I don't realize I'm hitting, and I don't know what it is. It's in the bottom right-hand corner of my iPad, because that's the only time it ever happens, is when I'm doing something at the bottom. So I want everybody to draw a square on their paper. We're just going to make this real interactive. Everybody draw a square on your paper, and we know that this is a regular quadrilateral with an apothem. So this is kind of going to be like one of those directed drawings that you used to do in elementary school, where your teacher would be like, now draw a circle in the middle of your paper and draw a bigger circle around it. And really, like, you end up with a picture of a snowman or something. So everybody draw a square. Now put a dot in the dead center of the square and draw a line straight down to the bottom of the square. Let's go ahead and look at what that looks like. We have a square. Put a dot in the dead center of the square. And then draw a line straight down to the side. You could have drawn a line to the other side or to the other side or up, but that right there is your apothem. It's the line that goes from the middle of the shape perpendicular to one of the sides. So actually, in this previous problem, the height of that triangle would have also been the apothem of the hexagon. You following? This height of the triangle would have also been the apothem of the hexagon. Let's go ahead and go back to our problem that we're working on. So this right here is our apothem, and it is 7 inches. Well, the apothem goes from the dead middle of the shape and down. So then if this is the dead middle of the shape, then this is 7. What is this up here? That's also 7, which means that the side length of this shape is 14. And because it's a regular quadrilateral, it means that all the sides are the same. That means I also know that this is 14. And if this is 14 and this is 14, how do I find the area of a quadrilateral? Or of a square, not a quadrilateral, a square or a rectangle? Area equals length times width. 14 times 14. I don't have that on the top of my head. I'm going to use a calculator. 14 times 14 is 196. So the area of this shape is 196. Now, if you know the definition of apothem, this is a very easy problem, because once we draw that picture, it becomes very clear what we're dealing with. If you don't know the definition of an apothem, this problem becomes very difficult. But now that we all know the definition of an apothem, because I just told you, this problem becomes very simple. All right, let's keep going. Problem number 5. This problem is going to most likely be seen on a 6 through 12 exam or a 5 through 9 exam. We're looking at direct and indirect variation. So suppose y varies directly as x and inversely as the square of z. When x is 16, y is 6, and z has a value of 2. find x when y equals 8 and z equals 4. So what do we know here? We know that y is varying directly as x and inversely as the square of z. So the first thing we have to do is find our constant. Like I said, this is likely going to be more on a middle or a high school math than anything else because we're dealing with direct and indirect variation. So the first thing we need to do is find our constant, because when we're dealing with direct and indirect variation, there's 99% of the time there is a constant. So if y varies directly as x, that means y equals k times x. There's your direct variation. Your inverse variation would be y equals k divided by x. So if y varies directly as x, there's that piece. And inversely as the square of z, that means we're doing combined variation right now because we have that and. So if y varies inversely as something, it would be k divided by something. And so we can go ahead and combine these as the square of z, not the square root of z, the square. The square of z is going to be z squared. Now that we have our direct, indirect variation equation, now we can plug in our values that they've given us, x, y, and z, to find k. And if you're just as annoyed as I am, welcome to the club. I'm tired of this thing disconnecting. So I apologize profusely. I don't know why it keeps happening. If you're an iPad expert, please tell me what I'm doing wrong. So we've got inverse and direct variation going on here. I'm going to plug in my x, my y, and my z to find k. So y equals 6 equals k x divided by z squared. Why am I trying to find k? So that I can plug k in to then find x. So 6 equals 16k divided by 2 squared is 4. 16 divided by 4 is 4. So 6 equals 4k. Divide both sides by 4. And I get k equals 1.5. Now I can plug my 1.5 into my equation that I've built. So y equals 1.5 x divided by z squared. Sam, thank you for that comment. That is excellent to know. Geometry is a weak point for a lot of people, but I'm glad you were able to follow along. So now I'm going to plug in my y and my z, and I'm going to solve for x because I now have k. So y is 8, k, solving for x, z is 4. Now I'm just going to use basic algebra or basic order of operations to solve this. This is something everybody needs to know. So while you didn't need to know how to set this all up, solving for a variable is something everybody needs to know how to do. So if you've checked me out, check me back in. All right. 4 squared is 16. So I have 8 equals 1.5x divided by 16. I need to isolate this x. So what I need to do is multiply both sides by 16 to get the 1.5x by itself. 16 times 8, using my handy dandy calculator, is 128. So 128 equals 1.5x. Divide both sides by 1.5. And I get x equals 85.3 repeating. And when I look at my answer choices, my answer is D. X excellent job following along with that problem. Again, if you have any questions, don't hesitate to drop them in the comments. Let's go ahead and keep going. Hopefully we'll get through a couple more problems before we have to close out tonight. Simplify. All right. Order of operations. This is one that tricks a lot of people. Let's talk about our order of operations. So, order of operations is PEMDAS. Please excuse my dear Aunt Sally, where parentheses and exponents are kind of together, multiplication and division are kind of together, and addition and subtraction are kind of together. This means that parentheses and exponents have to come before multiplication and division. But once I get to that multiplication and division, I don't have to do the multiplication before the division. I can do division before multiplication. In fact, I'm going to move from left to right in my problem. Let me show you what this looks like. So I'm going to do one piece of this problem at a time. Parentheses. So I'm going to look for parentheses or brackets. Brackets are just another set of parentheses. So I have a set here that needs to be done first, and a set here that needs to be done first. There's nothing for me to do with this. They just gave parentheses to separate those double negatives. So there's nothing for me to solve there. So 48 divided by negative 24 times 5 and 3 times 5. 3 times 5 is 15. I'm just going to go ahead and write that down and keep everything else the same. But this set of parentheses right here, this one's interesting. Really, all I have is two operations, 48 divided by negative 24 times 5. Which one am I going to do first? Some of you would say you would do the multiplication first because it comes first in order of operations. This is confusing. Yes, you're right. In PEMDAS, it comes first. However, in order of operations, it does not, because I'm going to move from left to right because multiplication and division are married. So they are partners. So it doesn't matter which one comes first. We just have to move from left to right because that's how we read. So I'm actually going to do 48 divided by negative 24 first, which is going to give me a negative 2 because a negative divided by a positive is a negative, times 5. And then I'm going to take this and bring it down. Negative 2 times 5 is negative 10, and I'm going to keep everything else the same. Now I have negative 10 minus negative 4 plus 15 divided by 3. What am I going to do next? The division. I'm not going to add or subtract yet because I'm still sitting in this section of my order of operations. So I'm going to do this division next. Negative 10 minus negative 4 plus 15 divided by 3 is 5. Now, what am I going to do? Again, we come to this juxtaposition where subtraction is actually before addition, but we can do it first because, again, just like multiplication and division, addition and subtraction are married. And so it does not matter which one we do first. We have to move from left to right. So I'm going to go ahead and convert this right here. A negative times a negative is a positive. So negative 10 plus 4 plus 5. We're going to continue it up here. Negative 10 plus 4 is negative 6 plus 5. Negative 6 plus 5 is negative 1. So our answer is B. Now, had you multiplied first or had you done one of the other operations first, you would have gotten one of these other answers possibly, and they know where those common errors are, those test writers. And so we want to make sure that we're We understand the order of operations and how it happens so that when we get to a problem like this, we can solve it efficiently and effectively. All right, it looks like we're going to have time for one more problem. So I'm going to do this one right here. Yeah, we're going to do this one because we have not done a graph problem yet. So the graph of h of x is shown below. On what intervals is the function increasing? So this is a weird, interesting problem. Increasing and decreasing refers to the function, what it's doing on the y-axis, not the x-axis. So when we're looking at the intervals are just the spaces that it's increasing and decreasing. This right here is a point on the graph. I can't be increasing or decreasing on one point. That would be like me standing on the side of a mountain and saying I'm going up the mountain, but really I'm just standing still on the mountain. I could go up or I could go down. So when we're looking for intervals, we're looking for gaps that we're increasing or decreasing on. When we talk about those gaps, we're talking about them on the x-axis. So this is where it gets confusing because let's just look for where we think this graph would be increasing. Let's just take a look. It looks like the graph is decreasing, constant, decreasing, constant, increasing, decreasing, decreasing, increasing, decreasing. I'll say that again. Let's do that one more time for those of you who are not as familiar. Decreasing, constant, because I'm not going up or down, so I'm staying constant. Increasing because I'm going up. Decreasing, decreasing, increasing, decreasing. Now, why did I go this way? And why did I not go this way? Because if I went this way, everything would be opposite. Well, I went to this way because that's the way that we read. We read from left to right words, so we read graphs from left to right. So which of these is increasing? We're increasing here, and we're increasing here. And when we talk about the interval that it's increasing, it's not from 2 to 3 and from 5 to 6. The interval is on the x-axis. So the interval is going to be from here to here and from here to here. Those are going to be the intervals that this function is increasing on. So if we look at our answer choices, from 5 to 6 and from 2 to 3, that's going to be the most common answer, or not the most common answer, but the most common misconception that people choose, because that's where the graph is increasing on the y-axis, but it's not the interval that the function is increasing on. The interval that the function is increasing on is going to be from 3.5 to 5 and from 7.25 to 9. It's not going to be all the way from 3.5 to 9 because in the middle of that, we had a point of decreasing happen. So we're not increasing on that interval of decreasing. If it said on what interval is the function decreasing, we would have to include all of the yellow. So we would have to include this interval, this whole interval, because it's decreasing that entire time. It's just decreasing at a different rate, and this interval. So we would have 3 separate intervals if it asked where it's decreasing. If it asked where it was constant, we would look at the gray, which is just one space. So it would just be one little section of the graph. All right, We didn't get back to that probability problem, and that's because there was a lot to that problem, and I was worried it was going to take up too much time tonight. So we'll do a few probability problems next week. We also have a couple more problems in this slide deck we didn't go over. So if you downloaded the slide deck from the link, and I will post it again, if you downloaded the slides from the link, we will go over the probability problem next week. We will also go over this Gardner problem, and we will go over this length, width, and height problem for rectangular prisms. For those of you who are taking your exam tomorrow, good luck. I'm sending you all the positive vibes. For those of you who are taking it later this month or later in the year, good luck to you as well. But I know there's at least one of you taking it tomorrow. I'm going to turn it back over to Dr. A for a special message. Thank you so much for joining me tonight, and I can't wait to see you next Wednesday. All right, Dr. A, are you there?
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.